There's a lot to be said about single users and user-to-user differences between handheld, manual methods. If you've got, 3 or 4 techs in a lab and they're having to use a mortar and pestle, any of our solutions that we would deploy for tissues or any samples for that matter, you're just going to take away a lot of that inconsistencies of results, and any variation you end up seeing ultimately becomes a variation between samples. Right? It's about the beads you're using and optimizing around the exact sample you want to use. Right? We definitely put a lot of time and effort into picking the right beads for our bead beating with our semi-automated devices like our bead mills. On one hand, that adds a lot of consistency downstream because you have less sample loss. You can recover more of your buffers to go downstream. It's just going to lyse everything there, push that into suspension, and then you can really build your assay around removing these inhibitors and things like that. Sometimes things like high amounts of SDS are needed to lyse cells, but at the end of the day, those high amounts of SDS show up downstream and they kind of throw off your elution buffers, right? If you're hand tailoring your chemistry and you were leaning on that SDS to lyse your cells, well, with physical lysis, you don't necessarily have that anymore. And so you can really tinker with your assay and go back to that. But every sample, when you look at a list of PCR inhibitors, there's all sorts of things that come through there that may end up contaminating your downstream. So, picking the right method to fit the right chemistry to fit with your lysis method is, that's where the marriage happens that creates ultimately high quality nucleic acids downstream, right? It's more than just a single step.